very welcome to you all. Thank you very much for taking part. Paul Hearn was going to come and be with us this evening, but he's had to opt out last minute. But he's asked whether we would mind recording the meeting to put on the BAA YouTube channel. Is that okay for everybody? Yeah. Whatever you say will be recorded. So take a little bit of care. Now, somewhere there's a record button. I don't mind. As long as you know it's going to go online. So I was told before by, I think it was Melvin there told me how to do it, how to start, or was it Ted, I can't remember. Start recording. Here we are, let's press that button. Starting recording and transcription, it says. We'll see if that works. So therefore, we're now recorded. So welcome everybody to this inaugural meeting of the Hydrogen Line group. That sounds a bit posh, of the British Astronomical Association, but I think we've got at least as many people coming from SARA, the Society of Amateur Radio Astronomers, for anybody listening online who doesn't know what SARA stands for. So, so the idea of this meeting tonight is to discuss and help each other to try and be able to detect the hydrogen line, mainly in the Milky Way, but possibly elsewhere if we all get very clever later on. So that's at 1,420 megahertz wavelength. So frequency, sorry, which is what. I'll just start off, but perhaps everybody could just introduce themselves a little bit, perhaps for about 5 minutes, say who you are and what excites you, and what you're hoping to get out of, what level you are when it comes to hydrogen line observing, and perhaps what you're hoping to get out of these meetings. So who should we start with? Let's start at the bottom. Andrew, let's start with you. Oh, I can't hear you. You're muted.
Can you hear me now?
Yeah, I can hear you.
Yeah, great. Okay. Andrew Luckley. I'm based in Ashton, near Epsom in Surrey. I'm a founder member of the UK Radio Astronomy Association. I'm also a member of SARA, so I've got hats on both sides of the Atlantic. I built this log periodic hydrogen line aerial about 10-12 years ago, since when I've done absolutely nothing with it. So I'm intrigued by this group and the possibility of connecting it up to my computer and some very nice low noise amplifier and whatever else I need, and actually detecting something.
All right, very good, excellent, thank you.
I've got a bit of a reputation for starting projects and not finishing them, so it would be great. It would be great to actually finish this one. I've got loads of other hobbies and interests, including metalworking. So if there's anything that I need to make out of metal to make this project fit together, I'm certainly up for that.
So we've got a metalworker. All we need now is somebody who does a bit of carpentry, and another member of this group has got a 3D printer, and we're well away, aren't we?
Yeah.
so Jeff,
I should also mention that I've got a 3-meter dish, which is in bits. I bought it as a kit, unused, again about 10 or 15 years ago, from a college which had bought it new and had never assembled it. It's been in storage ever since, and so that's sitting around looking for a use.
My wife and I went to visit the observatory of Mansfield in Nottinghamshire, and they've got a very nice planetarium, but they've got a building next door to it for their radio astronomy, and we noticed on the side of it was a 3-meter dish strapped to the side wall. Can look like it had been there for some time, clearly unused, waiting for somebody to come along and work out what to do with it. Anyway, should we move on to you, Jeff? Do you want to tell us a little bit about yourself?
Yeah, hi, Jeff Rodriguez in good old Cincinnati, Ohio, USA. A retired, semi-retired high school physics teacher who got into radio astronomy through projects for students. Went to a program through Pisgah National Research Institute, and got to have online access for students to use their Smiley 3-meter telescope. So that was awesome. Also, I worked with QuarkNet, which primarily deals with particle physics. I was looking for some other applications of cosmic rays for my detector. and I got into NASA Radio Joe and a SID detector. So I ran those at school until we got new air conditioning, and that kind of wiped out all my radio signals or anything at the school. When I retired, I joined up with the Cincinnati Astronomical Society on the other side of town. I never liked going there because it was too far to drive. But I said, I got more time now. And now all that my old equipment is there at their site, along with a 3-meter dish that was sitting there. People that tried to use it and couldn't figure out how to make it work. And I found some new technology that's a big dish for using the old stuff, with SDRs and things like that. So for less than $200, I got it running. Got some data, and everybody's like, "This is amazing," because they've spent like $3,000-$4,000 at it. It's not nowhere.
Wow.
So kind of circling back around, trying to get outreach to students. I've got a couple of high schoolers doing some research on the 3-meter dish. Just basically redoing the rotation experiment that I did last year. I finally got it working. So it gives me another set of data. Running, looking at motorizing it, trying to calibrate it, get a little bit more detail, and I'm starting to fall into the rabbit hole. Like, the more I get in, like, oh, this gets more and more complicated.
Well, do you know, I've only had 2 people here so far, and I've already decided that when Rich or Ted chair the SARA meetings, it's a lot harder work than it looks from a distance. I'm just going from the bottom up. Tony, do you want to tell us a little bit about yourself?
Sure, hi. So level 0 in hydrogen line observing. I did see your presentation at the RS GB. I think it was back in October, November, which was very good. My son was very impressed with it. So level 0, but I know a bit about radio and physics and stuff, work in mobile telecoms. So yeah, just looking forward to the journey.
Brilliant, thank you. John?
Yeah, I've been playing hobby radio since I was in short trousers. Did comms with the RAF. Is that, I see you putting your hand, is that loud enough? Paul?
Yeah.
I think Paul's cupping is that better?
Yeah, that's a bit better. Yeah.
Okay, right. Yeah, so I did comms with the RAF. I brought a lot of it home with me, as you can see behind me. Did the courses through Inaugnral Bank, played with their hydrogen line receiver, which is a 6-meter dish, thereabouts. But that was over 20 years ago, so quite a clunky system, without any sort of SDRs as we would use today. So looking forward to playing with all this sort of stuff. I managed to pick up a little preamp this week. The postman's been bringing little packages from China, little folded dipole, supposedly cut for 1420. So we've got the makings of a station of some sort or other.
I'm just wondering, looking at all that stuff behind you, which certainly to me looks very impressive. I'm just wondering, are you a single man or do you have a very understanding partner?
I have a very, very understanding wife.
She must be. But I can imagine all those people I saw at the radio convention in October would have been salivating at the sight of what you have there. Yeah.
It's a lot of 1970s rubbish, really, a lot of it, but yeah. And a big teleprinter in the middle of it. I could probably reduce the whole thing to a laptop and an SDR, to be frank.
Oh, such is true, such is true. So this is not in order of preference, by the way. All I've done is I've started at the bottom of my page because I can see you all, and I'm just literally moving up. So next in line we've got Paul and Heather here. So we were meant to just have Heather, but Paul's got and joined us, so that's great. Excellent.
Okay. No, I'll go first. So Heather Nichols, I've been doing astronomy all my life. I'm the chairman of the Marches Astronomy Group, and got most of the bits like John ACD, who lives about 5 miles from me, to do it. We've got a 3.5 meter dish out the back, so 3.7, and we got a 2.4, and we got a couple of other things, and we've been doing amateur radio for 10 years or so. So we do a fair bit there, and I'm also on the committee of the UK Microwave Group and so on, so that sort of thing. But although I've been involved with a lot of radio astronomy, I haven't had yet to receive a hydrogen line signal, so I'm starting very nearly at zero.
Is there anybody in this group that doesn't own a 3-metre dish? I mean, I don't own a 3-metre dish, but oh, you haven't got one either, Tony. I think you and I could set our own group up, the hydrogen line people who don't have a 3-metre dish. Oh, I think Andrew can join us as well. I know Ted's got one. I can't wait to find out what Melvin's got. If I tried to put a 3.7 and a 2.4 metre dish in our garden, they wouldn't fit. And my marriage would have been gone by the end of the week, so here we are. So Melvin, where are you, and how big's your dish?
Leading question. Right, I'm in Felixstowe, which is the east coast of England, answering your question. And biggest dish I've got 1.8 metres. It isn't mounted on anything, it sits on the ground and looks upwards. So it's good for doing transit, but that's about all. Essentially, my expertise, such as it is I was a satellite engineer for about 40 years. I'm retired now. So, dish antennas, cables, signals, anything RFE I know about. So far as software is concerned, it's a bit of a closed book. I also run a Linux computer, which Linux is largely on software, but all my H-line stuff is being done with a program called H-line software, which is about as simple as you can go. You loaded it, plug in a dongle, and it works. You don't have any setting up or anything. So I built a corner reflector antenna, then the grid antenna, which I went through the normal thing of putting mesh on the back and changing the feed to make it work properly. It still doesn't work very well. These terrible antennas, I wouldn't use them. And as I say, I've got a 1.8 metre dish, which we used a grand total of once to do a transit scan at Zenit.
Right.
So that's me. I need to know about software, preferably without using Windows, but I'm not sure if EDRA will run on Linux, no short term itself.
Ah, well, we have someone here who can tell us all this evening, so that you'll get the answer to that question. So when you say use H-line software, is that Alex Pettit's H-line 3D?
It's by a Danish student, and it was written about 4 or 5 years ago. It's on GitHub, but it's basically command line, and then it gives you a one-page output, which is hang on. I'm not sure if I can. You can't really see that, can you? It basically gives you one page outlook, which is where you are in the sky and what you see and correct it for velocity. So it's very simple. Doesn't do anything other than work. But if I wanted to do lots and lots of scans all added up to see more amplitude detail anyway, reduce the noise, and it couldn't do that, for instance.
Right, okay. Yeah. Okay, well, thank you. And Ted, do you want to tell us a little bit about yourself?
I'm a retired engineer, and I finally got some time, so I turned on my hobbies of amateur radio and astronomy, and now even radio telescopes. I've been playing with the telescopes for maybe 5-6 years, so I'm just a little bit ahead of perhaps you folks, and I want to share what I've learned and help as much as I can. I'm about an hour north of Denver, Colorado, over here in the USA, and I'm also a member of BAA anyway, so here I are.
Okay, thank you very much, Ted. Thank you. So, in terms of, so I sent out a message and asked folks what they were keen to talk about this evening, and basically what we've got is a rather extensive set of stuff. We might not be able to cover everything, but we've got hardware, cabling, software, and calibration. So, as I say, we might not be able to get through all of that little lot. But what do you think you'd like to start with? Have a shout out. What do you fancy starting with there? And I remember if you.
I think the cabling would be the easiest to start from the beginning.
Oh, okay. Would that suit everybody? Start with cabling. Is that the beginning? Okay, fair enough. So,
You got to connect everything.
okay. Who would I start? Go on then, Ted. Tell us about what cables you use on your big scopes behind you there to do your H-line stuff.
Working on it here. There we go. There's a picture, so we can start talking from there anyway.
Mm-hmm.
We see the antenna as a picture. I'll tell you all about it in a little bit. Over on the right.
I'll tell you what. Sorry a second, Ted. Perhaps, given that picture is very useful, should we just take a step back? Do you want to perhaps give us all a very quick overview of what components are required for a hydrogen line setup? As you've got a nice picture to show it there.
I think this is the picture that I have to describe it.
Yeah. So, do you want to perhaps just talk through the components? I mean, bear in mind, people online might be looking at this who don't know much about these things.
The antenna's way over on the right. The low noise amplifier is that no-elect thing, but we want to place that really close to the antenna so we don't lose any signal in coax loss. Now you got a signal that's amplified. You can run it down a long cable. I use 50 feet with no problem. I even use the wrong impedance coax, so I put it down 75 ohm cheap TV coax line. And as long as it goes down to some kind of receiver that provides the power, that no-elect Smart T shown on the left provides 4.5 volts up the coax, which seems to work fairly well. And that receiver is about the size of your finger and plugs into the PC. There is software for Windows and Linux.
Right, brilliant.
Where do we go from there?
Yeah, fantastic. So you're saying that from your experience, it doesn't really matter too much which coax you use, certainly not in terms of impedance.
Not as long as you're past the amplifier.
Right. Okay. The other thing you mentioned there was the need to have a bias T to be able to send a voltage up the cable to be able to power the amplifier.
Well, I think of a bias T as a separate device that inserts voltage, so that can be involved, and I certainly use those as well. But this picture doesn't show that. It's even simpler with the Smart T that does that for you.
Yeah, brilliant. Thanks. Okay. So, just say that I forgot, in my desire not to, or to give everyone else a chance to speak, I forgot to mention a little bit about who I was. So, just say that my name's Andrew Thornett, and I'm based in Lichfield, which, for those that don't know, is just slightly north of Birmingham, right in the middle of the UK. I live in a suburban house. So I'm not in any particular rural location, and about 400 metres or so from a massive Tesco's, and so probably lots of housing estates around, so probably quite a bit of RFI. A garden that's about sort of 5 to 8 metres across at max, but obviously a lot less space than that with all the shrubs and trees and things. A lot of trees around. I do get quite excited about hydrogen line work, and I started off with an ex-military array that I was given, which is 86 times 86 centimeters in size, and a 4x4 dipole array, and now I've moved on to a 150 centimeter dish, which is sold on eBay as a solar cooker for putting your kettle in when you're out camping to heat up the kettle. So that's my latest project. I also own one of. Sorry?
Have you got that working properly?
It's now working, yes.
Yes.
Yeah, I've just signed up to do a talk at the Western Sahara conference to describe it. But I have to collect enough data to be able to show a map of the Milky Way from it. Yeah, but it wasn't. I had difficulty getting it working, which maybe a little bit later I'll tell you what we found out was the problem, which is ridiculous. But anyway, the I have also one of Alex Pettit's Yagi, looking at Andrew's Yagi design there, that the and that's meant to be tuned perfectly to 1420 megahertz, but for the life of it I can't get the thing working, which is probably me rather than the aerial. So, but anyway, yeah, thank you very much for that, Ted. That's really great. So has anybody else here got any views on anything of those things? Yeah.
Yeah, well, the cabling, I was just going to piggyback on to what Ted put on. My system is almost exactly the same, except I think it's showing the bare bones LNA, and I have the one with a cover on it. It's really close. There's a couple of N-type connectors between the original dish, because I have a Vima feed with a Kumar choke sitting up bound that has worked pretty good with those dishes, with some adapters going back, and then the cabling, like about what he has, like 50 feet of cabling back to the computer, where the SDR has like a bias T that powers up everything.
Mm-hmm.
So that's the general setup.
I've just noticed we've lost somebody. Yeah.
We've lost Ted.
Ted, is it? Oh, I'm sure he'll be back in. Oh, hang on, he's waiting to come back in again. He must have had a bit of an issue.
What SDR are you using, Jeff?
The same one he showed on there with the Smart Key. I had to look on Amazon. Ted, can you bump that picture back up with the SDR? Like an Olectric NESDR Smart Key. And I have the Sawbird with H1 LNA instead of what that looks like a bare bones type.
I use the bare bones so I can use that 4-pin connector to control it a little bit more precisely.
All right. Just out of interest, Ted, what can you do through that 4-pin connector?
With the 4-pin conductor that my cursor is on, I can tell it to not read the signal in from the input connector, but instead read the signal from an internal 50 ohm resistor. And so right. I can use that for a reference sample.
All right, okay. I didn't know that was in there.
And by Ezra Hardware 2, it talks all about how to do that.
All right, okay. Okay. And so on my setup, I would just say that I now have some KMR 400, which is one of the sort of Me Too versions of LMR 400. So that's very low impedance. I'm not sure it was necessary at all. I did have RG58, so I think there's a couple of different things. One question is whether it matters whether the impedance is matched at 50 ohms, as we're not doing any transmitting. And I think the second question, though, is does it matter what the actual profile of the cable is in terms of the frequency it's designed to work at? Because I think there is an argument that RG58 tends to lose quite a lot of power at the higher frequencies. I don't know what you guys think.
Yeah, RG58, 59 should be good for a gig, but if you essentially your loss is related to the diameter of the cable. So your RG400 is lower loss than a 1/4-inch cable, which is I use a stuck with RG223 perfectly successfully over a 10-meter run. What I would say is don't go down below that, though. If you start using there's RG16, no, 316 is about an 8-inch cable. That is very lossy. But the rule of thumb is you need 20 dB more gain in your LNN, in it. I think everybody's case that's a new electric thing, than loss behind it, or at least noise behind it. So you can live with 10 dB of cable loss quite happily. So your 223 really isn't necessary. The reason your RG58 probably didn't work is it's not screened very well, by the way.
Well, I think I also had Ed talked about where the cable was located in respect of the LNA, the low noise amplifier. And to be honest, I was naughty. I had mine LNA located near the receiver, so it was coming from the aerial down the cable.
Any loss in front of the LNA, as Ted said, is very bad news. Don't do it.
I think it was very bad news. Things have improved since I've sorted that out.
Yeah. No, connect your LNA directly to the antenna. Do not use cable.
Okay.
Etc.
When you buy the cable, you should be able to see the decibel loss per foot based upon the frequency.
Yeah.
I think the RGBA is for below like a gigahertz or something, or a couple hundred megahertz.
It should be for 1 gig, but because we are all using fairly short runs, its biggest problem is more it's going to be it's a single screen cable. It's going to pick up a lot of interference, particularly in a situation where I live in houses all around. We've got Felixstowe Docks, which has got a very big radar for marine traffic, and every so often I get a 2 gig signal sweeping over. You've got to keep that. So
what sort of gain have the LNAs got that you're using?
they're all these new Alexa 40 dB.
40?
Yeah. So my rule of 20 dB behind it, you can have 10 dB of cable loss and 10 dB noise figure on your receiver. And the RTL SDRs, which all of these are essentially part of that order. So it will work. Incidentally, I actually do use an additional filter, but that's partly because it's just in front of the SDR. That's largely because I get radar pick up on the cable, on the outside of the cable, which is a bit more cheaper.
While we're talking, I've just connected a little folded dipole to a VNA. Folded dipole that was on AliExpress for a couple of quid, cut for 1420, and it shows quite a nice. If you can see the yellow line, but I can hold it up right. Oh wait, is that visible to you?
Actually, Ted, can you take your picture down so we can see in the light?
If I speak, will that bring it up large on your screens?
No.
No, because Ted's sharing his screen.
Is that big enough for you to read? Yeah, you can see the yellow now.
Yeah.
So that's a reasonable dip in return loss. Well, the way the scaling works on this thing is about 1430, so in the right ballpark. So that's quite encouraging for just a simple folded dipole element, which by its very nature should act as a filter to get rid of some of the other sort of out-of-band signals that are going to swamp the preamp.
If you take the touch screen pen and touch the line and move it along, there's a little dot that moves along until it gets the exact frequency that you want the recording to be on. So you can actually set it for 1420 in terms of what it's measuring for you.
It's pretty damn close.
Yeah.
It's there really.
Yeah.
That, so that's quite encouraging.
Yeah. So I mean, for those, sorry, yeah, Paul.
Yeah, I was going to say for coax, television, satellite television coax. Okay, it's 75 ohms. It's very well screened. RG58, for instance, is very open range. The TV's screen, and it's very cheap.
So you're talking about RG6, are you?
No.
Yeah, it is.
It is RG6.
RG6 it has a foil wrap as well. Because some of the cheaper coaxes, I mean, not all coaxes are created equally.
Yeah.
Unless you go for 214, which is double screens, thicker stuff.
But
the 213, I use is double screen.
Yeah.
For that reason.
Yeah, 213 is single screen.
Is it? Oh, sorry, 223. I use.
Yeah.
223, yeah.
223 is double screen.
I mean, while we're on this this subject, can I ask you how far away do you feel that your receiver and computer needs to be away from whatever aerial that you're using to collect your hydrogen line signal?
I was going to mount the whole lot at the feed, Raspberry Pi, straight on the back of a receiver.
Okay.
There will be no coax in my system. It will be straight on the feed point.
There's a danger you'll get interference from your Raspberry Pi.
Well,
Yeah.
it'll sit somewhere nearby, but yeah.
Well, you know, I use the house wall. It works very well.
Yeah.
How effective is building a Faraday cage around your computer if you've got it close to the aerial, do you think? And perhaps earthing it?
If you build one of those that works, you're a better man than most of us, I think.
Oh, right, okay.
They don't work. If you can't, well, you've got to sort out your earth loops and you'll be there forever.
Yeah. At those frequencies, there's no such thing as Earth, really.
Yeah.
If you work out,
You've got to get your Earth cable length matched in fact. And then the signals down.
This group is meant to show people how easy it is to do hydrogen line work, not leave everybody thinking it's really complicated.
It is very easy. Just do it the way Ted did, and it works.
Follow his instructions.
Yes, more or less.
Yeah.
I've got a question about filters. Working here at 1296 megahertz, I found that I've had to use a filter in front of the preamp because in some directions I was getting a rise of 14 dB of noise from interference, and this was strong out-of-band signals causing problems with overloading the preamp. So a filter before the preamp in many locations may be necessary.
So what filter are you using?
I'm using something that I've tuned from another frequency and modified. It's all rather nice silver plated, but it's been hacked around. The Sawbird LNAs have got built-in SAW filters, haven't they?
Yeah, they do. Yeah, I think the plus or minus 30 megahertz, I believe.
Yeah, they should be pretty good. Is that on the front end or is it behind the amplifier?
Oh, does anybody know? Because there's two amplifiers in it, isn't there? Because it's
So
cascaded.
the first amplifier is Sawbird and the second amplifier, a filter and a second amplifier. So you've got 20 dB before your filter, effectively.
Oh, it is 2020, is it? Yeah.
Yeah, it's 2020, it's the filter in the middle. Well, it did according to their documentation.
Right.
Right there, anyway.
Yeah. Okay. So that's what I was wondering about, because you used a separate amplifier there, Paul, and a separate filter, you're saying. You didn't use the Sawbird.
On 1296 I was using an amplifier and the filter was put in front.
Oh, right.
And it improved the noise in certain directions by 14 dB because of this problem of strong signals overloading the preamp. So this one.
And the other thing that I've seen discussed in various places is whether it's worth having two Sawbirds, one after the other, or one at the dish and another one just before the receiver. Does anybody have any views on that?
Not
If you've got it, you have to beware in those circumstances about overloading the receiver.
Yeah.
If you've got too much gain.
For the same reason that I said on the cables, if you've got 40 dBs in your Sawbird at the LNA, you're not going to have that much loss afterwards in any sensible system.
Yeah.
So you simply don't need it. If you did have an LNA, if you did have a second amplifier, it only wants to be 10 dB to overcome cable loss. And beyond there, it's not necessary.
So what we're saying then is that the ideal system involves your aerial, whatever we're going to use, then you're going to have your low noise amplifier and filter immediately straight after the aerial, ideally attached right to the back of it, and most people use the Neuralex Sawbird H-line LNA, but I suppose there are other options available, and then some form of coax which you don't need to be too hassled about exactly what it is. You can just go for RG6 or some other cheap satellite cable, and then you have a receiver at the end. People talk about the one that was discussed earlier on. That's the Smart T, isn't it? Personally, I use the RTL blog version 3, which was recommended in the SARA's scope in the box package. But I guess any SDR that will actually take you or pick up 1420 megahertz should be okay, I would have guessed. But it needs to be able to produce ideally a bias T current to go up the cable to power your Sawbird. Otherwise you're going to have some sort of power supply to plug into the Sawbird, which can be powered externally, but it's a right hassle if you have to feed power right up to your aerial. And I suppose there's a potential of interference as well. And then you need some computer and relevant software behind that. Would that be agree with everybody? Would think I got that right, or would anybody like to suggest there's any errors in that? No, all happy with it. Forgive me. I'm perhaps clarifying these things for the sake of anybody who looks online and perhaps knows nothing about the subject at all. So it seems to me we've done quite well covering hardware and cabling, but the one thing we haven't discussed is what aerial or antenna that you use for this purpose. Other than the fact that almost everybody in this group except me, Andrew and who else was it? I forget who else it was, and Tony there don't actually own a massive dish, but at least I got the 1.5 meter one, which only just about to start getting working. But it wasn't sold as a radio dish anyway. So you could do a lot with a 3 meter dish, but let's say, how small can you actually go practically?
A dipole works.
Yeah. Who's that? Like Melvin?
The top of the dipole works. Who was it holding up? Tony? I can't remember.
John.
Yeah, that will pick up the hydrogen line. You'll see a lump on the noise block. You won't see any resolution. You'll only see one spike. So it'll be there.
All right. So
I've done that.
So let's take that up. So something quite small, like a little dipole like that off AliExpress.
Yeah.
Horror of horrors if you're American. I know you. Something coming straight from China is not really allowed, but but if you actually want to be able to then pick up anything else on top of that, such as I don't know, perhaps even trying to map the Milky Way, what sort of size do we think we need then?
Well, when you come down a long way in size, it's not really acting as a dish. So you get to a point where it's just as good to have a Yagi as a dish.
Yeah, my corner reflector is effectively a 5.6 meter dish, which is tiny, and you can see the local line. One or two paces you can see a second line, but the resolution isn't there. The bigger dish, you get more resolution, you'll see more detail effectively. So the 3 meter dish, you'll see a lot more detail than you will with a 1 meter dish.
So you could do some.
1.5 will be a lot better now at its dipole array.
But we're saying you can do some element of mapping of the Milky Way and possibly weighing the Milky Way with 60 centimeters. You're suggesting?
You can do something, but yes. But that doesn't mean I'd recommend you go out and buy the 60 centimeter dish that's now on sale. It's a very expensive way of getting not a lot.
Yeah.
So what's the minimum to get a reasonable resolution?
That's what I was saying. The 0.6 works. The what's it called? The grid antenna works, which is 1 meter by 60 centimeters. Is it? You've got one, Andy, I think.
Yes. Yeah. Although so far my stuff's mostly done with the ptarmigan array, so that is 86 centimeters by 86 centimeters, and I've done a lot with that. very successfully mapped the Milky Way, done a sort of 3D imaging of the Milky Way, demonstrated dark matter, weighed it with Ted's help. I got to say, I've got to give him credit with a very large amount of Ted's help. In fact, I think we'll go further and say Ted has successfully mapped the Milky Way and demonstrated dark matter using an 86 centimetre ptarmigan. I was just there carrying out his instructions, I think. So, yeah. So certainly, I think 86 centimetres. I don't, other than the fact I've not managed to get Alex's disc Yagi to work yet, I don't really have any experience of using sort of Yagis to do this exercise, but I can quite imagine it should work quite well. Although I'm not quite sure the different types of aerial, how prone they are to be affected by sort of interference from elsewhere. I don't know, does it matter whether you've got a dish or a Yagi in terms of interference coming from the side, or maybe even signals bouncing off the ground or elsewhere or whatever? Is that important?
In principle, no, but it shouldn't matter whether you're using a dish or a Yagi. However, Yagis are not very good at front-back, what's called front-back ratio, effectively what you're picking up off the ground. Dishes tend to be better. And the reason I built the corner array is they are very good for off-axis interference. So although it's got low gain and not a lot of resolution, you actually do see more than you'd expect, because there's simply no pickup for anything else.
So tell us a little bit, Melvin, about your corner antenna. What's that made of? How do you make that? And what's it look like? And how does it work?
To be honest, mine is made of MDF and tin foil.
Oh, right. Okay.
I connect it with a metal probe in exactly the same as you would use in a tin can feed. It's in a shed outside. I can't show you it, but
so this is where you.
It's basically three plates of metal. Is essentially a corner reflector. So
yeah.
Take a cube, chop it off, so you've got three plates of metal. That's all it is. But yes, that's one. Well done. Exactly what they look like.
All right. Is that how you mount it, Ted? I don't like that. Okay, like that. Okay, fair enough. Okay.
Yeah, the main beam is 45 degrees from any one of those. I think it's 55 degrees from any one of those faces. So it doesn't go straight out the front of the triangle, funnily enough. It's confusing until you do the maths.
We weren't too worried about pointing. We were just going to get a signal and measure it, and then figure out where it was pointing from that. So, okay.
We wouldn't have enough resolution to enable that.
Well, we got signals, and we saw bumps, and we could plot them on the sky. That was fun.
Yeah.
Then there's the horn, which is four-sided, maybe pyramidal horn. And then you go to a dish. You know about this grid dish. Then you go bigger. And bigger is always better. It seems to work better, you know. Keep going and going.
Pretty wife objects.
That might be grounds for divorce.
I don't know. I'm sure that was Paul and Heather's dish that we just saw there, wasn't it?
That's a club, yeah. So come join the club in southeast Colorado.
Yeah. They say if your aerial didn't blow down over the winter, it's not big enough.
Right. Okay. Okay. For those who aren't members of SARA, I would just say that my latest bit of fun is using the 20-meter Skynet dish at Green Bank, which, if you remember SARA, you can do. So I've just been observing galaxies with that over the last week. So that's great fun. That's my new remote observatory. Okay, so so in terms of dishes, we got that sorted. We all get some MDF and some silver foil, and we're well away. So that brings us on to the next thing in the discussion, software and calibration. I guess perhaps should we talk about software first? Ted, would you be happy to perhaps? So I think most people that I'm aware of are either using SDR, or I suppose I'm based on Windows, and they're either using SDR Sharp or they're using Easy Radio Astronomy, but I'm sure there are many other options. So perhaps what other options, or what things are you guys using who have had a go at doing hydrogen line? Anyone?
Well, I'm using the SDR Sharp with the average plugin, and I asked questions if I've looked at a bunch of different, like SDR Angel. There's one H-line. I saw someone talk about great looking plots. And then this other one on GitHub, Virgo spectrometer, something that not only measured gives you nice plots, but supposedly can motor, use the motor with the dishes to do like a mapping of the galaxy.
All right. Okay. Okay.
All right. You got everything.
Oh, is that the lot? Oh yeah, very good. Very good.
There we go. Well, that's a bunch of them anyway. Here's your SDR Sharp. I learned with MIT Haystack with the SRT. That goes back in time. On Linux and maybe now on Windows we have GNU Radio. Spectre Cyber was a hardware box. You plugged a cable in, and it talked to your computer directly. So it was the receiver built in. Over there in Portugal, they have a bunch of programs as well to collect hydrogen. We already talked about H-line, and my software is kind of built on top of this as well. And you talked about Virgo, and the folks that make those horns in West Virginia have a program called Despera, and so they use GNU Radio as well. And there are more.
So, would you like to tell us a little bit about Easy Radio Astronomy, Ted?
Okay, is everybody kind of comfortable? This can go on for a while. Let's see.
So for the next 3 hours, Ted's going to give us an introduction.
I want one of Andrew's beers.
Yeah, that's it. Okay, well, I'm just pointing out an opportunity here for you. Let's see. I think I'm sharing. I think my mic is on. This is good. I was disappointed with some of the software available, so I started writing my own during all the COVID problems, and it worked out fun. You can give this a try, or enhance it, or use something else. It works out. It's pretty flexible in all kinds of ways. If we took a simple antenna like these wires on a PVC pipe held together with zip ties, we could see what to do. This was just metal wires up at the top, held by a zip tie, held by another zip tie in a pipe. And then the driven element is by Ken Britton. If you line them all up and connect them up, you can see we connect the L and A in the middle directly to the antenna as short as we can, just with an adapter here. And then I have an adapter to go off to cheap TV cable F connector and run about 50 feet into my house where it's nice and warm. I put all that through the pipe. I kind of tape it up. I put a plastic bag over it. I put another plastic bag over it and turn it upside down. And I was doing measurements with this. I put a couple feet at the bottom to hold it steady. Okay, that was the simple antenna I was trying. But what about the software? What can we start collecting data with? Many methods. This was the picture I showed earlier of how you hook it all up. I think we've covered that part. And then on that PC, once you have my software called Easy Radio Astronomy, or ESRA, you run Python, and you reach over into the directory where the ESRA programs are, and pull out the program called EasyCollect.py, and run that. By default, it will come up with something like this. It shows you a bunch of information. There are ways you can enter in where you are on the Earth, and that gets written into the data file. You can write where the antenna is pointing at the sky, what azimuth, what compass setting. This one is 180 degrees to the south, and 45 degrees up from the horizon to the south. We can see 256 red dots along here on the left for the power measured at 256 different frequencies, all centered here on 1420 or so. This other graph on the bottom shows the last 24 hours of data of the average of all those values. It's kind of helpful. It's not what you're looking for, but it's I'm not using up any computer power to present it. This next graph in green is is the same signal, but only over the last hour. And up in blue is the same signal, but over the last 500 samples. So you can grind it. What we see down here in the bottom is a rather normal fluctuation over the course of a day. Let's talk about that a little bit more. There's a way to remove that. And so if you run the same program as before, but now add 2 more words out here, something about the center frequency for a reference, and we're going to look not at 1420 megahertz, but someplace where we don't expect hydrogen, like 1423 megahertz, or pick another number. Then you get a graph more like this. It's got different numbers up here at the top. This one is a reference sample shown because it's got an R. Over here it's got a really nice smooth curve because indeed there's nothing found up at 1423. It seemed to be clean at least when I was measuring. And that can be used as a reference where there is no hydrogen. If we go a little bit later, we would see that the R goes away and the sample number increases. So this must be a sample from the sky. I call that an antenna sample. And it's the same kind of curvy thing, but in the middle, there's a little bump of something. So that's the hydrogen showing through. There's a button up here in the top right called RefDib. And if you turn that on, then you get to see these different, we get to see the antenna signal divided by the reference signal for each and every frequency. And that way the hydrogen shows up a little bit better. That's a comforting sign. We can see that the signals oscillate here. We'll get into that. The file it creates is pretty simple. It's all text. You can read it. You can edit it. You can improve it. There's a bunch of header information at the top, and then long lines, lots of them. The long lines start with a date, and then hours, minutes, seconds, and then, in this case, 256 numbers. Those are the values of all those red dots. And then you take another sample, and you do it again. Big, long lines. Now you're ready to actually analyze this. You got a file. The program will create something with the year, like 2023. The month, like August. Let's put August in there for 8. 11 would be the day, and 00 is the hour in UTC when it started. You could analyze that one file, or 2 of them, or maybe a directory full of them. The signal values will oscillate. The red is shown here for reference, and the antenna signal from the sky is shown in blue. So we make a sample and reference, a sample and antenna, a sample and reference, a sample and antenna, and we can compare the difference between them. You see that the top pattern kind of has a dip and a shape, and down here the red has about the same shape. But this is only for 50 samples. Let's look at a lot more. Here's the rest of the graph from 0 hours of a day all the way up to 24 hours of a day. And we see this same pattern where it goes up in the middle, comes down, and then eventually starts working its way up again. It turns out that's related to temperature out there. In my location here north of Denver, Colorado, 6 p.m. local is about 0 time UTC, and so the evening starts to cool off. With the electronics at a cooler temperature, they work better, and the gain is higher, so they give out higher numbers. 12 hours later at 6 in the morning, everything heats up and starts to go down in gain. And then in the afternoon, you might have clouds or thunderstorms, and so it's rather unpredictable. The point here is, though, the blue line that we care about, that it has the hydrogen in it, is rather nicely tracked by the red line that does not have the hydrogen in it. And with that, we can get rid of this curvy shape to a large degree. Reference samples. Here's many days graphs showing the same thing. Happens every day. In the evening, it cools off. It warms up in the morning, and then in the afternoon gets rather chaotic. But the program certainly does more. This is frequency climbing upwards around a 0 frequency where we expect the hydrogen. And then from 0 hour all the way up almost to 24 hours over here. Each one of those 256 dots is shown as a vertical line sample. And sure enough, along the way, near 0 Doppler, we see some bright stuff and even a curvy thing. We don't need these frequencies at the top or these frequencies at the bottom. The program can clip those off, and it shows a little bit brighter. There's a curvy hydrogen snake showing up. There's even a bright line down the middle where we get an artifact from the SDR. Optionally, you can remove that too, and suddenly that line goes away. But we see a curvy line here. It goes up and down. The frequency is changing because of Doppler. Sometimes we're on the front of the Earth looking, as we go around the sun with great speed, we're on the front of the Earth looking out the front windshield of the Earth. And 12 hours later, we'll be rotated around looking out the rear windshield of our Earth as we travel around the sun. And that velocity can be calculated by Ezra and then applied so that we're actually shifting up and down this spectrum. And that makes the curvy snake less curvy down the middle. If we take, for each one of these vertical line samples, we can put a green dot on the point that had the highest value. And then the highest of all the green dots gets the yellow dot. What's nice to see is that for a lot of the day, the strongest signal seems to be our hydrogen signal. Maybe our antenna is good enough. This is the same pattern, but now with including 3 days of data. And we start to see some patterns recreated, or repeated is what I mean to say. And sure enough, with the maximum values for each one of these vertical lines, it looks like the important strong value is right down the middle where the hydrogen is. That's encouraging. Ezra makes lots of plots. This tries to put them all on one page. Down at the very bottom, we see galactic longitude. When we look out at the plane of the galaxy, that's up and down away from the plane of the galaxy. Sometimes you're pointing up above the plane of the galaxy, and somewhere in the day, normally you're pointing down below the plane of the galaxy. I would expect there are signals to be strongest when we're looking actually down the plane of the galaxy, where this crosses zero. There's another cross here, another cross here. The program conveniently puts a vertical line where those are, and sure enough, with the ant-big signal, we start to see bumps of energy at the right places. Here in this pink line as well. You can take that and plot it across the sky. We were studying a line, this thin black line, all the way across the sky in 24 hours. And then on top of that is this green offset vertical line, offset value line. Over here it shows more energy when it was in this area, and a little bit more energy over here in this area. How convenient that that's where the galaxy is. It seemed to line up pretty well. If you put in the azimuth and elevation and where you are on the Earth, and your clock is set correctly, then Ezra will do all the math to do this for you. It'll even average many days onto the same plot. We want to find out where the maximum of this bump is, maybe about here, but it's really down here on the black line. Same would be true over here, but let's let the program do it for different elevations shown here. Oh, now where's my plot? Oh, I'm sorry, okay. It's coming up later. Or did I take it out? Oh, well, okay. So I did it for several different elevations, which show up as different declinations on the radio sky. Sure enough, here's all the elevations coming along here. Oh, I know, it's coming up. With all these little bumps here, 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 here. They seem to line up with the galactic plane. And now I start to talk, where's the maximum on here? Where's the maximum bump on here? Where's the maximum bump on here? And the program will do that for you and show them up as little green dots. And you can compare that to the galactic plane shown in red. It works pretty well over here, but I think the signal is so weak I kind of bounced around over here. Maybe more data would average that out. Instead of green lines, you can do it with different various colors, showing the intensity, with bright yellow down here on the bottom, showing as a bright value. We can take all the data between there and have the computer interpolate for those points that don't have data, and we start to fill out the whole screen. We see a U coming down and a U going back up. So we're starting to plot the radio sky. In fact, we can do it in galactic coordinates as well. Here's the plane of the galaxy at 0, above and below the plane of the galaxy. The center of the galaxy must be at 0, 0, over here someplace. Now, when we plot the power data in this coordinate system, we start to see down the center where that seems to be the brightest part of the sky in the galactic plane. That's comforting. This white empty spot is the part of the sky I can't see from my Earth location. The Earth was in the way. And instead of having the computer give misleading guesses, I simply blocked it out. This was that earlier plot showing where those drift scans are flying around on the galactic's coordinate system. But let's have the program cared only about those that are near galactic 0 and maybe between -5 and +5 degrees. So 0 degrees and maybe 5 degrees near. Let's look at just those samples, like a filter. We can start to see those have different interesting shapes. Over at 118 degrees, over about here, right? the signal came in like this. At the 0 Doppler frequency, near the 1420 frequency we expect, sure enough, we see hydrogen. And in fact, we also see approaching, no, I have to get it right. Negative. Anyway, different velocities. So there's another bunch of gas over here, and even another bunch of gas over here that we also picked up along our line of sight. The next program along is Easy Gal. It starts to look at the galaxy. It takes the same frequency information, runs it through a formula to get velocity spectra with different scale. Here we see a bunch of things at no velocity with respect to us here at the sun. And then we see a bump over here at about maybe minus 70 or so, minus 50. Then it comes down here and drops suddenly rather sharply. That is one spectra. We take that one spectra and line it up with all the others as vertical lines. That one was at 118, about out here someplace. And sure enough, there's a bright peak. There's another peak in the minus, about minus 50. And it goes down and then has a sharp drop off on the bottom. On here we can kind of see these droopy lines. It's hard to see, I will say. And then there's a triangle up here, sort of. If we look at the professional versions of this same plot, it looks like this, where we see that triangle quite sharply. Those are made up from transmissions from galactic arms that are closer to the galactic center than our sun is, the intergalactic arms. And these hanging down here like beads are from galactic arms which are farther away from the sun, from the galactic center, than our sun is. So those are the outer galactic arms, it turns out. With that, we can do some math and actually know the distance from the sun out to where that packet of energy was. We can start radially plotting the distance from the sun for those different energy levels. We can start to see some arm here, and there's some red thing going on over here too. We can interpolate between the data. Now with the galactic center in the middle, here's the sun. We can see an arm and maybe something else going on out here. So with a $20 antenna, wow, yeah, you can do something anyway. With free software, it runs on Linux and Unix. Linux and Windows, sorry. But with bigger antennas, like a 15-foot or a 16-foot, even more can happen. You can get a plot that has just more detail. And using this NASA plot that labels these arms with the sun down here and the galactic center up at the top, we can actually label the arms shown on that previous graph. Okay, yeah, but that's just in the galactic plane. If we think of one line out here, one galactic longitude, one angle from the direction of the galactic center at 85 degrees, what about the data we can collect up and down, above and below the galactic plane along this line, in and out of the screen? Yeah, another program called Easy Glan for galactic longitude can plot that stuff. But it's pretty close to this galactic plane, this horizontal line along here. What happens if we increase that, magnify it, just by increasing the angle displayed? A multiplication of 5 kind of spreads the data out a little bit better, and then the program can interpolate between those, and we start to see it much more. Here's the sun, here's a galactic arm, or maybe two, I don't know. another one out here, and another one further out. What's interesting is they are not in the galactic plane. They're kind of curving up. The edge of the galactic plane is curved, kind of like a potato chip. Okay, well, now we got 3D data. For 3D points in space, we have hydrogen density. A brighter color would have more density. And with that, we can start plotting that information in 3D space as planes going out into space, with the sun at the very center down in the middle. We could have it rotate, or we could fly our spacecraft around the galaxy, always looking back at the sun, and we can see that galactic plane in 3D. And I'm having fun with other kinds of 3D things with Ezra. So Ezra's there. Give it a try if you want. It's free. Runs on Windows and Linux. I'll put the link in the chat. There's lots more on that web page. There are videos describing what's going on in detail. There are a lot more introductory videos. Let me know if I can help. I'm not pushing too hard, but it's an opportunity. Back to you, Andy.
Thanks very much, Ted. Yeah.
The hell with advertising.
I thought, I mean, would you guys like to see Ezra in action? Yeah. So this is going to sound like we're doing a sale, a duo for a sale. It's not really. It's just a program that we know a lot about. So might be good next time for somebody to talk about SDR Sharp or other alternatives. Here we are. That's in action there. That's sort of live at the moment, collecting data. You won't see it change very much because I've changed the. If you look at the top, just below the new file bit, it says EZ-col integ quantity 550000. That's actually on this particular computer that's running that. That's about 4 to 5 minutes of integration time, which I now run. The default's so about
100. It says it's 101 seconds as integration down there.
Oh, it's 101 seconds.
What you're pointing at, and so that is the number of readings to make one sample that gets recorded in the file. You can make that a big number if you want. It kind of smooths things out.
It also gives you smaller files to process. I was getting to the stage where some of my data was taking 4 days for EZCon to analyze it. So if I just stop that, oh, I wanted to show you something else. Sorry, just stop that. Okay. So Ted there was showing you, this is really to show you the results that can be had with something around the 1 meter level. So my 86 centimeter ptarmigan behaves roughly the same as a 1 meter dish. So just to show that you can actually do quite a lot with that level.
Possibly a silly question. Is there a favoured polarity for feeds at 1420?
Right. Do you mean direction of the waveguide?
Horizontal, vertical, left to right?
I can show you a nice little picture there that answers that question.
They do differently.
Sorry?
They really care.
Sorry, it's just a presentation I've got. I'm sorry to disturb you. There you are. That. If you have a dish that's got a longer axis, you want it to be orthogonal to that, as you can see on there. The other thing is these Neuralec mesh dishes where they have a longer axis in one direction versus the other. You want the longer axis to be east to west, because the way what Ted didn't mention was the way this software is working. We're not actually using any complicated hardware to follow the sky, just literally pointing in one direction and then leaving the Earth's natural turning to give the samples across the sky over 24 hours, which the software then calculates. That's called a drift scan. And in my case, this is my ptarmigan array here, but as you can see, it's literally on a very simple wooden mount there, which I've made, and that works very well. And yeah, it's not particularly accurate. I just changed the holes that are in those battens. I choose which one is being used to change the elevation, and then I use a digital inclinometer, which you can download free of charge on your phone, to actually indicate exactly what the elevation is, and just plug that into the software. You can do this with a cantenna, which is just a coffee can, and that works quite well as long as you get the measurements right. So this is the sawbird here that everyone's been talking about, LNA. They're about £50, and that's what I use as a receiver. I'm quite confident it doesn't really matter too much which receiver you use, as long as it will cover the frequency range. And that's just SDR sharp with the IF average plugin, which is the other major alternative, and that's the one that's currently recommended in the scope in the box package that Sarah are selling. And there's a link there for Ted's Easy Radio Astronomy there. Again, just showing data collection in action. Over this number of elevations, which was about 10 elevations or so, this was the map I was able to produce using that ptarmigan array. And it maps quite well on the arms there. And these are the things I thought I could see. Some of them a little bit with the eye of faith, but some of them are very obvious. Now there's this business, if you follow line of sight, and the velocity then translates on the left hand side, translates into well, colours here indicate power levels on the right hand side, and this is what Easy Radio Astronomy does a good job of doing, of retranslating that back into the left hand side and then mapping it.
So we're mapping frequency, which is the same thing as velocity, into distance. We finally get a point in space in a direction.
So once you've done that, as Ted says, velocity versus distance, this graph comes off Wikipedia. It's not mine. And this shows the difference between something with dark matter on the right-hand side versus something without dark matter on the left-hand side. And the main difference is that you can see the outside of the galaxy is moving much faster on the right-hand side compared to the left-hand side. So they describe it as being like a bicycle wheel on the right-hand side. And the explanation is meant to be that there's a load of extra matter on the outside of the galaxy, which we don't know what it is. That's the idea. On the left-hand side, what we've got is this sort of dropping off exponentially with time, the velocity, and this is what you would see, for example, in our solar system. So if I move it on here, TED software here produces the graph on the left hand side for you. So that's not my data on the left hand side, that's again Wikipedia data showing velocities of, or speeds really, of the planets versus radius or distance from the sun. And you can see the further out the planet is, the slower it's moving. That's following Kepler's rules, Keplerian rotation. And my data there is on, which is the green dots, is on the right hand side, and you can see that definitely isn't following that Keplerian rotation of the left. In fact, it's much closer to a flat line there, representing the same findings as you'd expect from that dark matter graph previously. Oh, that's weighing the Milky Way with my data as well. This is quite a robust measurement that you can do with your H-line data very easily, and it's independent of your ability to be able to measure dark matter or not. You can go out to about 8 kiloparsecs, which is where the sun is. You can't go any further than that. This is what I use to collect my data, just some mini PCs running Windows, because I know Windows well, and you can just buy these things quite cheaply off eBay. What else? Okay, so that's one of Alex Pettit's Patch Yagi, the one that I've got that I can't get to work. And this is this parabolic solar cooker dish that I got for £50 it cost me. So as you can see, a number of petals. They do tend to rust very readily, so you need to keep spray painting them. And you can see there where the cantenna is, the green thing, is where you would normally put the kettle. That's not an ideal way of holding it. That's just my initial setup, and that's me then changing it over to a better way of holding the cantenna. Again, I built another one of these wooden mounts, and there it is mounted now, ready to observe. And ignore this stuff because I was having some difficulty getting it to work. And the reason I had difficulty getting it to work... Oh, sorry, first of all, here's some plots, 3D plots that I've taken. This is the ptarmigan data. So just to encourage you. There we are. So, but I had difficulty getting the solar cooker to work, and eventually found out that I had a cable that had a reverse polarity SMA. Control Shift M. Control Shift. Can you hear me now?
Yeah. There we go.
Yes. Sorry about that. I pressed the wrong button. So my apologies. I was just going to finish off there with one last statement. Just say I discovered that I had a cable with a reverse polarity SMA connector on it, plugged into a normal SMA connector, so there was no central conductor in the coaxial cable connecting across, and in fact it was giving, as a result, it was giving a 32 decibel loss on the signal. And putting in an extra adapter immediately changed it to 2 decibels, so it's a vast improvement. And now I'm collecting hydrogen data, which is great. That's me done. Sorry, Ted, you were saying something else when I came back.
We noticed you were gone. I was filling in the time.
Oh, right, okay. Is there anything else you'd like to say?
I'm good. No, we were just talking about you when you left, so don't worry about it. I don't know where.
Don't worry, we're just talking about you.
That's a matter. Don't worry about it. Don't worry about it.
By the way,
is there?
Are we still recording?
Yes. Yeah, fine.
Okay. I didn't know if your leaving changed that.
No.
So we've been talking lots about software. What was another topic?
Those are the topics that I had. So, is there anything else that anybody particularly would like to talk about tonight? Or are people getting a bit tired and perhaps want to put it off to another day?
I just got one brief question. Just taking my log periodic aerial.
Yep.
Is there any way any equipment I can connect that up to give a readback of the frequency response of the aerial without trying to detect anything, just to see whether it's built to the right dimensions for hydrogen line?
John, do you want to tell us about nano VNAs?
Well, this is a tiny or a nano vector network analyzer.
I think I've got a VNA. It's not that one, but I've got one somewhere.
There's a smaller one I've got as well that's very hard to read. Hang on. This looks familiar in one of these boxes under here. He says, no, not that box either. Stuff everywhere here. Oh, here we go. The battery life in this one. So this is a nano VNA. Same sort of thing. It thankfully has a USB interface, so you can actually bring all of those traces off such a tiny screen, separate them out into individual traces to look at return loss and other characteristics on your PC. Because quite frankly, that's almost too small to read. The other useful thing, which you mentioned earlier on, a manometer with the usual phone or a little device like that one, comes off eBay for about £3.50. Gives a reasonable 2 decimal place digital readout for elevation. So much more precision there than you'd ever need on a Yagi such as yours. But it works very well for finding other satellites. Just point off to one side, set the elevation correctly, and then azimuth through until the signal peaks. Never fails. As easy as.
So what can you see? So perhaps talk us through, John, what you can actually see on one of these VNAs that would help Andrew and other people to test their aerials.
Okay, well, I'm not, without getting too complicated with it, I'll hold it up to the camera if that works. The yellow line with the dip in the middle is the return loss, which is basically showing the point of resonance in amongst all the other more convoluted Smith charts and other complications that need more interpretation. But essentially, you're just looking for a resonant dip in that yellow line so that you know you've got resonance there, which also acts as, with this folded dipole, a way of rejecting out-of-band strong signals that would otherwise perhaps overload your preamp. So in a way it also acts as a filter, a very crude filter, but it starts the process. You talked about gains of preamps earlier, sort of 20 dB, 40 dB. I've had some of these arrive this week. This is a 20 decibel one, 12 volts supplied, supposedly covers 1 meg to 3 gigs, so that should cover the band nicely. That's a 20 dB. Another one came in the same package, should be good for 1 meg to 2 gigs, and that claims 64 dBs of gain, which might be a bit on the high side, to flatten the front end of a unsuspecting RTL dongle. I feel I might need to put some attenuation around that, or use a better SDR play or other. That's not very much to look at in the camera really, is it? But that's an SDR play, RSP1, so or something of that nature that might have a bit more resolution. It's all part of the experiment, isn't it? Yeah. The other antennas I've been building more for doublement on Inmarsat, but we won't go into that here. This is an L-band QFH antenna. So this is centered on about 1.5 or 1.6 gigahertz. I bought 2 or 3 of these and made one slightly oversized. But it's obviously the actual PCB behind it isn't the right size to come down to 1420. But a bit of re-engineering, something like that, would give you, depending on the nature of the dish you're using, if you're using a dish, this would give you a good wide beam width, because this is basically right-hand circular polarization, covering in its basic form horizon to horizon. So it's got a beam width of 180 degrees in all directions. So depending on the type of dish you've got, if it's just a beaten hemispherical dustbin lid, then that might actually work quite well. So it's all part of the experiment. We'll see what works. Try and make the system as generic as possible so I can swap things in and out and see what results we get.
Wonderful, wonderful. Maybe one day so you might be able to give us a bit of a talk on the different traces on these VNAs and perhaps an idiot's guide to how they could be used, if that's possible.
for me, it would be an idiot's guide, I have to say. No, you can start trying to interpret Smith charts and go down all those rabbit holes. Essentially, the simplest trace is the return loss, or in ham radio CB speak SWR. You're just looking for a point of resonance, which also basically the converse is, of course, it's not resonant where you don't want it to be. So it acts to reject signals outside of that band. So as long as you've got a nice dip at 1420 or thereabouts, you should be in safe territory with it. If you haven't got a dip there and it's elsewhere, then your antenna isn't going to perform as well.
Right. Okay.
Putting it as simply as that, without getting too complicated. Other crazy antenna designs. This is where you get click happy late at night on AliExpress. Is a spiral cut left-hand circular PCB antenna. It claims to be 800 megahertz to 8.5 gigs left-hand circular, which of course off a dish would make it right-hand circular. I've not actually brought that to bear yet, but it'll be interesting to see what it actually does as a general, not just for radio astronomy, but for generally trawling the sky, looking for interesting signals, which is partly what I do with all this stuff behind me. I mean,
it's very interesting to hear the different types of antenna that you've got, but it's worth saying to folks that this is all, I mean, there are obviously different ways of doing the hobby, but if you're just looking for a simple way of creating a waveguide for your dish, then a cheap one, then a Cantenna works well. You just I've made mine. I mean, the fact mine works is amazing. So it's one of those larger coffee tins, not the smaller ones, but the sort of large sort of ones that you might buy for a scout troop or something like that. And then you need a chassis connector, RF connector to go on the side, and then some bit of metal to go on the inside. I used a straightened paper clip, literally, just soldered onto the inside of it, and then you just have to make sure it's the right distance up from the bottom of the tin, and then you have to make sure that the paper clip's cut to the right length. And once you've done that, then it sort of works, and then you can just turn it upside down and use it at the focal point of your dish, or alternatively aim it towards the sky and create an extra bit on the end to funnel stuff into it.
Andy, I think I need to leave now, so I'll say good night to everybody.
Yeah, before you do,
I'll watch the last few minutes on the
well, but before you do, would people like to have another meeting after this to follow this through, or is one enough for everyone?
I think more would be good. I think probably each of the subjects we discussed this evening, probably get a meeting on each of those, or multiple, I think. But yes, I mean, lots of good inspiration.
So let's just perhaps set a date. When would you like to have that? In a month's time, perhaps? Would that be good?
Good.
So 14th of April, how's that?
Yeah.
Okay. 14th of April, and I'll send out a Teams invite, and I'll also ask you if you can just send some requests for what topics you'd like us to discuss at that meeting, and then I'll be going around to see if I get some volunteers to talk on them.
It'd be like an amateur radio net for radio astronomy.
Sorry, what did you say?
It'd be like an amateur radio net, except for radio astronomy.
Oh, right, yeah. Okay.
if you're a hammer.
Okay, thank you. Yeah. So as far as yeah. So all the best then, Melvin. And shall we perhaps call a halt for this evening then? Or does anybody would like to carry on talking about anything else?
Good for me.
Okay, well, thank you all very much for...
Now and drag a dish out of the hedge and start putting a feed in front of it.
I'm going to be interested to see what you managed to get all happening with these 3-metre dishes you've got hanging around. I'm shocked how many people seem to have a 3-metre dish just stuck around the back of the shed.
Mine's parked, the 3 metres parked on the drive. It's the 3.8 metres that's down the back of the shed.
Oh, gosh. Gosh. 3 metre on the drive. So how long have you been married for, John?
They're still good. No, it's on a trailer. So it's it evades any kind of planning issue as well. So you could park it anywhere, as long as it's not more than 28 days. Then you have to move it. But as soon as the planners find it's on a trailer, they're not interested.
Good tip.
Sorry?
I was just saying that's a good tip.
Yeah. So trailer towers are where it's at. Definitely.
Yeah, it doesn't say how far you have to move it. 1 inch would probably be enough.
That'll do. It's not fixed, you see.
Yeah.
That's the cunning plan. No, the 3 metres got a feed on it for 10 gigahertz for X-band, so that's well, we're using a bigger one, ultimately a bigger one for this game, but in the short term, probably a 2.4 metre, because that's the most handy. That's also mounted on another trailer.
Oh,
you
gosh.
never know when you might need to turn up with one.
Oh, gosh. Well, I'm very impressed. Very impressed.
I'm thinking put some rails on the roof and just move it from one side to the other.
You need 2 of them and do a bit of interferometry.
We have a variable baseline then. Yeah, we could do this.
Yeah. Well, it wouldn't be fixed, would it? That's possibly how they get away with the very large array, because they can move all the antenna around.
Sure, Bernard Lovell didn't have all this trouble.
No, he had other problems instead. Okay, thank you all very much indeed, and I'll look forward to seeing you next time.
Cheers, Andrew.
All the best to you. Bye-bye now.
Thank you. Good night, all.
Bye-bye now.
Goodbye.